So, are any of you familiar with Archimedes? What did he do? Oh, there is a screw, Archimedes screw. Yeah, he was an old dude. He stuck his foot in a bathtub. And what did he say? Eureka! That's exactly right. All right. So what Archimedes realized was the weight of the fluid displaced is equal to the weight of the object when floating. The weight of the fluid displaced is equal to the weight of the object when floating. So we could write that algebraically. The weight of fluid, what's weight? mg. So the weight of the fluid, so m fluid times g, is equal to the weight of the object, which maybe m object g. How about that? M object g. Sure. So, oops. Let's look at a container of fluid like this. Got some water here, some air out here, and maybe we've got an object of science floating in it. What would the free body diagram of this object look like? Definitely a weight force down. What would be up? Oh, there you go. There's a buoyant force. F buoy. So if this object is floating, is it accelerating? So the acceleration is 0. So what's the sum of the forces then? So when you sum the forces in the y direction, they equal 0. What are our forces then? F buoy minus m object g is equal to 0. How about that? So then F buoy would equal m object g. What was m object g equal to in terms of Archimedes' principle? M fluid g. Do we measure fluids in mass? No way. We usually measure it in volume, and we can relate mass to volume using our density, right? So what's mass in terms of density then? The density times the volume times g there. So rho v is our substitution for the mass of the fluid. So this would be the density of the fluid and the volume of the fluid displaced, and that's really important. So this is the buoyant force. This is the density of the fluid displaced. The volume of the fluid displaced. And then our little g is the acceleration due to gravity, just like always. So the buoyant force is the weight of the fluid displaced, or rho fluid volume fluid times g. You are in a fluid right now. There is a buoyant force acting on you. What are you displacing? Air. Air has density. You have volume, and you have displaced your whole volume. Now, is your weight force greater than the buoyant force on you? Yeah, so you've sunk to the bottom. It's like your sunken treasure.